You are listening to the Vocal Technologist. Spoken tech for your ears.
Welcome back, everyone. We're here to cut straight through the dense technical material and pull out the engineering wins you really need to know about. This is our Tech Tuesdays session, focusing today on, well, practical web dev insights, some big architectural lessons, and what's actually happening with AI in our workflows.
That's right. We're filtering for the actionable stuff. The goal today is to look at these recent shifts where people are finding real speed, maybe why they're ditching serverless, surprisingly, and the kind of engineering wisdom that cuts through the usual hype.
Okay, let's jump right in then. There's this trend, it feels almost like going backwards, the serverless reversal. For years, it was all go serverless, scale infinitely. But then we hear about Unki, an API key service moving away from Cloudflare workers back to stateful Go servers. That feels weird, right?
It definitely sounds like it goes against the grain, yeah. But this is all about performance for their specific workload. The really interesting part is why they left. Unki needs to check and manage access state constantly. And serverless, well, it doesn't really do persistent memory by design.
Ah, right. It's ephemeral. So how were they even managing state before? Must have been tricky.
They were basically fighting the architecture, lots of complex caching layers, data pipelines, just to shuffle state around between function calls.
Okay, can see how that adds up.
Yeah, and it meant high latency. Every single check involved extra network trips. They were spending more energy, engineering effort, just managing the lack of state than on their actual product logic.
So the complexity just wasn't worth the serverless promise in their case.
Yeah.
Did the switch actually pay off?
Massively. Switching to straightforward, stateful Go servers let them use simple in-memory batching, which is like a much simpler way to handle high-throughput reads.
Right.
Solved the complexity problem almost instantly.
Right.
And the payoff. A huge 6 times performance improvement on their core API checks.
Wow, 6 times.
Yeah. It's a great reminder, isn't it? Progress isn't always about the flashy new tech. Sometimes it's about finding that simple, stable solution that just fits your problem.
Absolutely. Chasing trends can sometimes bite you with unexpected complexity. Okay, speaking of simplicity making life easier, let's talk about some big tooling updates in the JavaScript world. Stuff focused on efficiency.
Yeah, a couple of major wins here, really aimed at reducing that mental load for developers. First up, the React compiler v1.0 is out.
Okay.
And this isn't just a minor tweak, it's a build time tool that automatically optimizes your components for React and React Native.
Automatically. How does it manage that without us rewriting everything?
It handles memorization for you. If you've worked on big React apps, you know the pain of manually wrapping stuff in use memo or use callback just to stop unnecessary re-render.
Well, yeah.
Well, this compiler just does it. It figures out where optimizations are safe and applies them. It gets rid of a whole category of boilerplate and potential little performance bugs.
That actually sounds fantastic. Automating the tedious bits. Nice. What was the other big one? Bun 1.3.
Ah, yes. Bun 1.3 is a pretty big deal because it really solidifies Bun's ambition to be like a full-stack JavaScript runtime. It's not just about speed or package management anymore.
So what's new?
Well, you get a full-stack dev server now with hot reloading built in. It's got clients for things like MySQL and Redis baked right in, so integration is much simpler. And crucially, some important security features.
Security is always key. What specifically?
They've added bun.secrets for handling encrypted credentials properly right out of the box, and built-in protection against cross-site request forgery, CSRF.
CSRF protection built in. That's handy. It saves developers implementing it themselves or pulling in extra libraries.
Exactly. CSRF is when an attacker tricks a user's browser into making requests on their behalf, right? So having that baked in makes Bun feel much more like a complete platform for the whole dev lifecycle, including security.
Okay, great stuff on architecture and tools. Now, let's zoom way in. You mentioned a sort of hidden HTML gem. Something small, but powerful for accessibility.
Yeah, this one's a really practical tip. We're talking about the output tag. Honestly, not enough people use it.
The output tag.
Right.
Why is it better than just, say, using a div and sticking some ARIA attributes on it, which I feel like I see more often?
Mostly just inertia, I think. People know ARIA roles help screen readers, so they reach for that. But output is the standard HTML element specifically for this job.
And the advantages?
Built-in accessibility. It's designed to automatically announce value changes to screen readers. You don't need custom JavaScript event listeners just for that. Plus, it links directly to the input elements that control it using the char before attribute. Just Cleaner, more reliable than building your own structure with ARA on generic divs.
Simpler and more standard. Got it.
Yeah.
That's exactly the kind of practical knowledge we aim for. Okay, let's shift gears into some surprising engineering tales. First up, this story about a tiny bug, a locale-specific bug, that apparently crippled the Kotlin compiler for years.
Oh, this is a classic. It shows how easily basic assumptions can break things in global software. It goes back to 2016, I think. A software engineer in Turkey reported this really weird error with the Kotlin compiler,
Okay.
and eventually they tracked it down to lowercase, the function that converts text to lowercase.
Wait, seriously, to lowercase. How on earth does that break a compiler?
Linguistics. It turns out the Turkish language has two different I's. There's the dotted I, like in English, and a dotless I.
Right? I think I've heard of that.
So if you take the string IFO and make it lowercase in English, you get info. Simple. But on a system set to a Turkish locale, to lowercase IFO actually produces unfo with the dotless A.
Oh, okay, so the compiler was expecting info maybe for like internal messages or lookups.
Exactly. That tiny difference, that dotless O where it expected a dotted I, meant that crucial internal lookups just failed.
And it only happened on Turkish systems.
Yep. Caused the compiler to crash or just act weirdly. And it took 5 years to properly diagnose and fix. Because who suspects to lowercase? It's a fundamental reminder code that works perfectly fine for you. Might have these hidden, culturally sensitive bugs lurking.
5 years. Because of a dotless face. That's incredible. Okay, next surprising story. A developer getting so fed up with DRM, digital rights management, they basically went to war with the Kindle app.
Yeah, the motivation was pretty simple, actually. They just wanted to read their legally bought books offline, maybe in a different e-reader app that they liked better. But the Kindle Web DRM was designed specifically to stop that.
Right, DRM is meant to be tough.
Yeah.
How did they even approach it? I imagine it was heavily obfuscated.
Totally. Layers of obfuscation. Randomized character sets, fake font hints to confuse scrapers. A real cat and mouse game, like you said.
So if the text itself was mangled, how did they reconstruct the books?
This is where it gets really clever. They shifted from analyzing the code to analyzing the visual output, what you actually see on the screen.
Visual output.
Yeah. They use techniques like pixel-perfect matching and perceptual hashing. Essentially, they taught a program how to read the rendered glyphs on the screen, decode them, and piece the original book back together into a clean EP file. Pure technical ingenuity.
Using image recognition to beat code obfuscation. That's pretty wild. Okay, let's switch gears slightly to security. A quick but important one. Credential stuffing. We know it's bad, but what are the real defenses we need?
Right, credential stuffing is everywhere. Attackers grab username password lists from one breach and just hammer other services with them automatically. Relying on users having unique passwords or even just MFA isn't quite enough anymore because the attacks are so automated and scaled.
So if the attackers already have potentially valid credentials, what stops the automated flood?
It has to be layered, and it has to be behavioral. Yes, MFA is good, breached password checks are necessary, but the really critical stuff involves things like aggressive rate limiting, using device cookies to recognize trusted devices, and deep behavioral analysis.
Behavioral analysis, meaning what?
Meaning the system doesn't just check if the password is right. It asks, is this login coming from a weird location? Is it happening at an unusual time? Does this device look suspicious? Is this account trying way too many logins? This leads to risk-based authentication.
Ah, so you only challenge the user with extra steps if the behavior looks risky, even if the password is correct.
Exactly. You assume the credential might be compromised and look for other signs of attack. That layering is what gives you real resilience.
Makes sense. Okay, final section. Let's talk AI in our development workflows. There's been tons of hype, but what are these LLM coding assistants still, well, kind of bad at? The overconfident intern problem.
That analogy is actually pretty spot on, and for a couple of key reasons. First, they don't copy-paste code like we do. They sort of remember patterns and rewrite them from memory.
Right.
Which sounds okay, but it means they can introduce subtle errors. They might miss an import or get an API call slightly wrong, especially when fitting code into a complex existing system. Things a human carefully copy-pasting wouldn't mess up.
So they kind of hallucinate slightly incorrect code, even if it looks plausible.
Pretty much. And the second big flaw, they're terrible at asking clarifying questions. If your prompt is a bit vague or the problem needs more context, they tend to just make assumptions and charge ahead.
Ah.
They'll often brute force a solution that technically works but might be way over-engineered, poorly structured, or just verbose. They prioritize generating an answer over asking if it's the right answer.
Okay, let's make that concrete. We heard about someone using AI to build a feature, right?
Yeah.
The auto-update system for the Ghosty terminal. How did that actually play out?
Yeah, it's a good real-world example. The developer found the AI wasn't great for the core complex logic, but it was really useful for things like UI prototyping and code cleanup, generating boilerplate to connect the new logic to the UI, that kind of thing.
So, an assistant, not the lead architect. What about the cost? People worry about token usage.
That was the surprising part. The whole feature took about 8 hours of actual time, and the total cost for all the AI interactions, the prompts, the generated code was just $15.98.
Yeah. $15.
Yeah.
That's basically nothing for potentially hours of saved work on the boilerplate stuff.
Exactly. The cost barrier is incredibly low.
But, okay, cost is low. But what about quality? We're seeing these newer, smaller, faster models like Anthropic's Claude Haiku 4.5. They're cheaper, quicker for coding tasks. Is there a trade-off?
There definitely seems to be. There was a direct comparison done, tasking different models with a WebSocket refactoring job. Haiku 4.5 was fast, yeah. But it produced 62% more code than the larger, maybe slightly slower Sonnet 4.5 model. And despite writing more code, it scored 16% lower on quality and correctness.
Wow, 62% more code for 16% less quality. Why so much extra code?
It goes back to that overconfident intern thing. It just defaults to being verbose, generated extra classes, unnecessary helper functions, really descriptive variable names. Basically, it over-engineered the solution.
Yeah.
It seemed to prioritize being thorough in its output over actual maintainability or elegance. Which, you know, for us, maybe, the Vocal Technologist crowd, thinking about long-term systems, that's a critical point. Cheap and fast isn't always better if it sacrifices clarity and stability.
Right. Okay, so let's try and tie this all together. We've gone from big architectural shifts back to simplicity to tiny bugs hiding in plain sight to the real-world limits of AI helpers. What's the common thread here?
I think if you zoom out, the big engineering philosophy that emerges is this. Real progress for really good engineers seems to be moving away from valuing cleverness and complexity just for their own sake, and moving towards prioritizing clarity and stability, whether that's ditching serverless for a simple Go server to get that 6x performance, or just using the standard HTML output tag for accessibility. The focus is shifting to durable, understandable systems that solve the actual problem in the simplest, effective way.
That focus on clarity and stability feels like the core takeaway. Build things that last and that others can understand.
Okay, before we wrap up, I want to leave you, the listener, with a final thought to chew on, building on this idea of simplicity and AI. We heard about the rise of home-cooked software domain experts, people who aren't coders, using these AI tools to quickly prototype custom software for their specific needs. It lowers the barrier to creating simple tools.
Democratizing that initial step.
Exactly. So here's the question. If the simpler foundational software needs within businesses start getting met by non-coders whipping up AI prototypes, what does that mean long-term for professional developers?
That's a really interesting question. Does our role shift even more towards integration, security, scalability?
Yeah.
The hardening of those simple prototypes into production-ready systems?
Maybe. Definitely something to think about as you navigate your own work, looking for those simple, stable solutions. Thanks for tuning in to this exploration of what's really driving modern engineering.
Yeah, great chat. Catch you next time.
Spoken Tech for your ears.